Hello and welcome. This is going to be our lecture video for April 13th. We're going to be reviewing for the Trig mini quiz. So our goal today is to review what we've learned so far in Trig. There's a mini quiz tomorrow and a test next Monday. We'll be wrapping up the first Trig unit. And all that's left is just the second Trig unit before the end of the year. So go ahead, get your notes out. Just taking notes today. That's all there is for today's lecture. Try along with these problems. I think they're going to help you a lot for that mini quiz and going forward with Trig, because we're going to be touching on a lot of different subjects. Okay, so which of these graphs is secant and which of these graphs is cosecant, and explain how you know. Well, I think the trick is you go ahead and you sketch in a wave that hits at all of these peaks, and you see what kind of wave it is that you've made. So if I sketch a wave in here, and where there's a vertical asymptote, we're going to cross 0, then you can see this is looking a whole lot like the cosine wave. So if purple is cosine of x, then the red line is 1 over cosine of x, which we call secant of x. Let's try with the other one. I'll put a point at the maximums and minimums. All right, at the vertical asymptotes, we will cross the x-axis. And this wave right here looks a lot like the sine wave, which we know starts at a midpoint. All right, so if this is sine of x, then in red we have 1 over sine of x, which is also cosecant of x. All right, and so that's how you can tell these two apart. They look very similar, but secant is going to be symmetrical over the y-axis. Cosecant is going to be anti-symmetrical over the y-axis, or we could say it's symmetrical over the origin. All right, here's our next question. What is the range of the following? And then it tells you it is being specifically graphed in degrees, but you could tell that because our h value is already in degrees. Now, one thing I'll tell you is that this it being graphed in degrees thing is a total red herring. It's not going to affect the range at all. That's something that would affect domain, because it's an input related unit. The range is the output. So the range is all about the values we can hit with y. All right, so normally if we just had y equals sine of x, doesn't matter degrees or radians, this has a range of -1 to 1. So that is the range of our parent function. Range. Now this has been shifted. One thing that happened is that it's got an amplitude of 4. So if we just had y equals 4 sine of x, all right, the amplitude moves 4 in both directions. So we're going to have our maximum be 4 higher, our minimum be 4 lower, or 4 times lower. So now our new range is -4 is less than or equal to y is less than or equal to 4 is our new range. All right, the next shift I care about is that +5. So if we have y equals 5 sine of x plus 5, that's going to move every point up 5. So it's going to move our minimum up 5 from -4 up to +1. And it's going to move our maximum from 4 up to 9. So 1 is less than or equal to y is less than or equal to 9. And that's our new range. All right, and we're done. That's our final answer. We didn't cover all of the transformations, but the 3 and the -40, they don't affect range. Don't affect range. Or is it affect? I think when I'm using it as a verb, I think it's affect. I don't know. Send me an email if I use the wrong effect, affect. All right. So just some more practice problems. We've got a radian measurement here. We want to convert it to degrees. We know it's a radian measurement because of that pi there, and we don't see the little circle that's not there. So we know this is radians. How do we convert? Well, we got to multiply by a ratio and we know is true. Well, the one that I've asked you to memorize is that 180 degrees equals pi radians. All right, so the pi's are going to cancel out. And we're going to get negative 3. We can put the negative up top with the 3. Negative 3 times 180 is negative 4, or negative 540. There's still divide by 4 on the bottom. Divide by 4, and we get negative 135 degrees. If we needed to convert degrees back to radians, then you would flip over this conversion factor here and do it as pi over 180. Notice degrees was on top, so that's why it became our unit. All right, find this angle. Well, these are always a little bit tricky when the reference angle is given from the y-axis. So just to make my life easier, I'm going to fill in this 40 degrees over here from the x-axis. All right, now I'm going to retrace my spiral counting by 180s until I get to this point right here. So here's where the spiral starts. I go a half circle, that's 180, 360 up to there. Doing the greatest job tracing. Okay, we'll do another full revolution, gets us to 720. So right there is 720. Go another half revolution, we get to 900, but then you have to add in this extra 40. So this is 940 degrees. Sometimes you have to subtract away that reference angle depending on how it's given. Here, the reference angle is part of the whole angle. But then we do one last thing. We look at the very start of the spiral. Do we start by moving down or moving up? That will tell us whether this is positive or negative rotation. This is negative rotation. We started by going down first. So it's a negative 940 degrees. All right, we got two angle measurements in radians, and we're being asked if they're coterminal. What do you think? Are these coterminal? All right, let's find out. So 10 pi over 9, we want to find its difference to this. So if we subtract this other angle, the negative 26 pi over 9, we'll find the angle measurement between these two angles. How do I get from this angle to this angle? That's what subtracting two angles always tells you. It's like the angle in between. All right, so minus a negative becomes a plus, so this becomes a 36 pi over 9, which becomes a 4 pi. All right, so that's the angle in between. Angle in between. Now to figure out if these are coterminal, we have to see if this is divisible by 2 pi. So is 4 pi divisible by 2 pi? That is 2. So this is an integer. So yes, coterminal. All right, these will land at the same terminal side. There's just two full revolutions in between them. All right, what's the measurement of this arc? So let's make it clear. We're asking for this length out here. All right, what is that length there? So the technique here is, well, if we know the radius of the circle, we can find the circumference of the entire circle and then just multiply it by the fraction of that circle that we're including. Okay, so let's find the whole circumference. So circumference equals 2 pi r. Another good one to memorize. Comes up a lot. It's not too hard. So circumference equals 2 pi r. This is our radius. This is going in for the r. So the circumference here equals 18 pi inches. So that's the whole way around. but we only went 45 degrees of the way around. So what fraction of a whole circle is that? Well, to figure that out, we have to do 45 divided by 360, because 360 is a full circle. And this here, I'm pretty sure gives us 1/8. Let's see, how many times does 45 fit into 360? Is it 8 times? Yep. So this is 1/8. So the whole way around is 18 pi, but we only went 1/8 of the way around. So I'm going to multiply those two numbers. 1/8 times 18 pi equals 18 pi over 8 inches. But the top and the bottom are divisible by 2, so it's going to become a 9 pi over 4 inches. And that's how I want the answer, with the pi still in it. Don't simplify it down to a decimal. All right, if we see a question like this, where we just have some words floating above a triangle here, this is what we're solving for. So I hope that's clear. We are trying to find cosine of theta. If we see this here, we're not just trying to solve for theta, we got to find the cosine of theta. All right, and what you'll see is you don't actually ever have to figure out what theta is to figure out what cosine of theta is. Here's how you do it. First off, we need to label these sides as adjacent, opposite, hypotenuse. Now, which side lengths do we want for cosine? So cosine of theta is going to be equal to the length of the adjacent divided by the length of the hypotenuse. That's the ka in SOHCAHTOA, C-A-H. Well, I don't know the length of the adjacent, so how I find that is Pythagorean theorem. A squared plus b squared equals c squared. 11 squared plus unknown b squared equals 11 root 5 squared. Let's see, this is 121 plus b squared equals, that squared gets distributed, so this becomes 121 times 5. Root 5 squared just becomes a 5. Let's see. I should simplify on this side. 121 times 5. 605. Subtract the 121 from both sides. B squared equals 484. Take the square root of both sides. B equals the square root of 484. So adjacent right here is root 484. We're almost done. Now we just got to plug in hypotenuse and adjacent. And so we get square root, I want a different color, of 484 over 11 root 5. Now the issue here is that we don't like square roots in the denominator. So I'm going to multiply the top and the bottom by root 5. So now I've got cosine of theta equals 484 times 5, the square root of 2,420 all over 11. Now let's see if any perfect squares fit into the 2,420. The obvious first one to check is 4, and that fits in 605 times. 605, is that divisible by maybe 25? Does not. What's another perfect square that could fit? Maybe we'll do the factor tree method. Let's see. I can tell it's going to be divisible by 5. So that's a 121 and a 5. 121, that's 11 squared. So 11 times the other 4, it looks like we can take a 44 out. Is that how that works? No, 11 times 2. We can take a 22 squared out, which is the 484. Oh, I didn't realize that was a perfect square. That would have saved us a lot of time. 44 is 22 squared. So let's actually just go back up to that step and turn the 484 into a 22. Then we multiply these. Should still be a times 5 on the bottom there. We've got 22 root 5 over 11 times 5. 22 over 11, that simplifies to just be a 2 root 5 over 5. So final answer, 2 root 5 over 5. Got to remember how to simplify our radicals. Was it obvious? Let's see. I guess at this step here, I shouldn't have combined these. I should have just taken the square root, and then I would have taken the square root of 121 times 5, and then I could have pulled out the 11. That would have been the absolute smartest way to do that, but this still worked out. Okay. Solve for theta. Let's see. So from theta's perspective, I am given the hypotenuse and the adjacent. So if I consult SOHCAHTOA, that tells me that cosine is going to be the trig function that's going to help me find theta here. So cosine of theta equals, we could say adjacent over hypotenuse, but let's fill in the actual numbers, 10 over 16. That can be simplified, but it doesn't really matter. It can just be left like that. What we need to do is get rid of the cosine so theta can be by itself. So we're going to do inverse cosine to both sides. So that will cancel out this cosine. And we'll be left with just theta on the left-hand side. And then this is something we can just plug into our calculator. But be careful, whatever mode our calculator is in is the unit it's going to give us our answer in. So I'm just going to be in degree mode. Sometimes I like to work with degrees. And then I'm going to do second cosine of 10 over 16. And that gives me 51.3 degrees. All right, solve for x. All right, so now we're finding a side length given an angle and a side length. So from the angle that we're given, that's not the right angle, the 26, this x over here is the opposite, and this 15 is the hypotenuse. So the trig function that relates opposite and hypotenuse is sine. So I know the sine of 26 equals opposite over hypotenuse, x over 15. To get x by itself, you multiply 15 to both sides. Make sure we're in degree mode because this is given in degrees. I'm going to do the sine of 26. Press enter. I get the ratio. Now I multiply by 15. And I get 6.58. And we'll just say units because we don't know what the unit of length is here. But it's definitely a unit of length for x here. All right. A couple more trig functions. So here, if we're being asked tangent of theta, the theta is this angle here. I want to make that very clear. So theta is not unknown. It's just not also plugging it in up here. This is how it looks on the homework. This is how it's going to look on the quiz. So just get used to this. When it asks it like this, what it's really asking is what is the tangent of pi over 2? Okay, tangent of pi over 2. A little bit tricky. Because tangent is opposite over adjacent, but I don't see an opposite or adjacent here. I don't see a triangle at all. So what I do is I take that terminal side and I pull it off of the y-axis a little bit. Float it into the first quadrant so that you can make a little triangle. And from the interior angle here, the opposite is a positive 1. The hypotenuse is a positive 1, so that's hypotenuse, that's opposite, and the adjacent is 0. It just looks like it has width right now, but that's really a 0 right there. So now I can do opposite over adjacent. Opposite over adjacent is just 1 over 0, which is also known as undefined. So the tangent of pi over 2, undefined. All right, secant of negative 29 pi over 6. So I've got to figure out what this angle right in here is. I'll do it in a different color. I need to figure out what that. It's not really noticeably different color. We'll do purple on top. Need to know what that is. So, well, from this reference angle, we can kind of figure it out. One is that the unit is a over 6. So that makes me think that this radian measurement in here might be something over 6. Probably a pi over 6, especially the way it looks. But let's just see. We'll find that by figuring out the whole rotation to this point, and then we'll subtract away the negative 29 pi over 6. So let's see. We'll count by pi's. So pi, 2 pi, 3 pi, 4 pi, 5 pi. So it's 5 pi. To get all the way, including that angle, let's get rid of the negative 29 pi over 6. I'm going to have to make this a 30 pi over 6 minus 29 pi over 6. That does indeed give us pi over 6. So we know this angle in here, that interior angle without a sign, is a pi over 6. Pi over 6. Okay, so that's also known as 30 degrees. So this is a 30-degree angle. If I pick a point out here on that terminal side, descend a line straight up to the axes, I can construct a 30, 60, 90 right triangle, which we know has side lengths 1, 2, and the square root of 3. But now I look at its orientation in the plane here. I see that for this side length, we're coming to the left, so that's actually a negative 3. And for this side length, we're coming down, so that's a negative 1. All right, what is the ratio for secant? Actually, before I ask that, I can label these as opposite, hypotenuse, and adjacent. All right, so secant is 1 over cosine. Cosine is adjacent over hypotenuse, so we want hypotenuse over adjacent, which here equals 2 over negative square root of 3, but we don't want a square root of 3 in the bottom. So I'm going to multiply by root 3 over root 3. I actually do negative root 3 over negative root 3. That already looks negative. That way I'll get rid of the negative at the same time. And I get negative 2 root 3 all over positive 3. All right, cotangent of 0. Let's draw a 0-degree angle triangle. So it has side lengths 1, 1, 0 for the opposite, adjacent, and hypotenuse. Cotangent is the opposite of tangent, so it's actually adjacent over opposite. So adjacent over opposite is 1 over 0, so this is another undefined. Okay. Here we're given an equation. We're asked to find the amplitude, vertical shift, period, and phase shift. So the amplitude is the number in front of our trig function. The amplitude here is 3. Vertical shift. Well, that's the number at the very end, and we're going to say up or down. It's a positive, so it's up 1. The period, we need to do a little calculation for period. So period is 2 pi over b. Here the b value is a 4, so it's going to be 2 pi over 4, which equals pi over 2. So our period is pi over 2. So this is cycling very, very quickly. And for the phase shift, that gets its own formula as well. That's h over b. The h value, remember to always flip the sign on this, so it's actually a negative 2 pi over 3 all over 4. That 4 is going to multiply to the 3, and we get negative 2 pi over 12, which is the same as negative pi over 6. But then for phase shift, what we'll say is pi over 6 to the left. That's what negative means here. All right, so that answers the first one. Now we've got to graph this one. And one thing, don't be thrown off by it, but the vertical shift has been moved to the front. Sometimes you'll just see this. It's not standard. It should be at the end, but we can deal with it. It's not too hard. So what I need is a standard cosine wave. So that's going to start at a peak, and it's going to cycle back to a peak after 2 pi. All right, so these 5 points will be my key points that I'll move around with these transformations. So I got the cosine taken care of. Let's deal with this 3 here by changing the amplitude to 3. So now I'm there, 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 and there. I'm 3 times as tall off of the midline. All right, next thing, we'll deal with this plus 2. Every point's going to move up 2. So there, 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 and now I'm going to actually erase these points so they don't confuse me. All right, here's my new wave right up there, and that covers the amplitude, the fact that it's cosine, and the vertical shift. Now we got to figure out the new period of this function. So it's 2 pi over b, so 2 pi over 2, which equals pi. So everything's got to get squished so that it cycles every pi. So it goes from a maximum to a maximum every pi. So that means this minimum is now at pi over 2, and these midpoints are at pi over 4 and 3 pi over 4. All right, and then we can repeat it so we can get some more points over here now that we can see them. And I'm going to erase the old blue points that we don't need. Okay, so we are up to this wave right in here. All right, and then the last thing is to deal with the phase shift. So that's h over b, which is 11 pi over 6. Leave the negative behind. It's not actually part of h. All over 2, which becomes 11 pi over 12. And that's to the right. But the period here is only pi. So moving 11 pi over 12 to the right is the same as moving 1 pi over 12 to the left, which would be just not even half a unit here. It'd be a third of a unit. So all of these purple dots are just going to move just a little bit to the left, which is the same as moving this purple dot all the way over to the right here. And now I can finish graphing this by connecting these up. The curve. All right, and on the mini quiz, you're not going to be necessarily graphing, but you do now have to know all of those transformations we just talked about. Okay, let's see. That's that for this video. Have a good rest of your day.